Well, we are absolutely going to have a great time today solving some absolute value equations. So you have to isolate the absolute value by moving terms that are not inside the absolute value bars to the other side using addition or subtraction. I'm just reading this to you, blah, 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 blah. You need to have, this is important, you're going to have the absolute value on one side of the equal sign and something else on the other. Now, here's the deal. Absolute value, remember, absolute value, I don't know if you remember this, so I probably should tell you just in case you don't remember, is the distance from zero. You might want to write this down if you don't remember that. The distance from a zero. So remember your old number line, right? Here's a number line. Here's zero. What this problem is saying here is my number's distance from zero is 5. So 1, 2, 3, 4, 5. It makes sense that x would equal 5, right? But my little friends here, we have got a little super secret thing going on. What if this little x goes out the door and turns to the right, goes 5 steps, it lands at 5? What if that little minx goes out the door and turns left and goes 5 steps? Where does it land? -5. So when you have the absolute value, you have to set it equal to the number and equal to the opposite of the number because the positive and negative directions. So x could be 5 or x could be -5. Both of them are 5 steps away from 0. So here's a little hint. Do you see the two little bars? Two little bars, you're going to set up two little equations. So here on this one now, we've got x minus 1. So if I go back to my little drawing here and I say, what if x minus 1 goes out the door and turns to the right? Well, x minus 1 could land at 5, right? But what if x minus 1 goes out the door and turns to the left? Where could x minus 1 land? It could land at -5. So you're going to take those two sticks and turn them into two equations. Then you're just going to solve the regular old way. We're going to add 1, so x could be 6. We're going to add 1, so x could be -4. Now what you have to remember when you're looking at this is you're not saying what number is 5 away from 0. You're saying what number, when I take 1 away from it, is 5 away from 0. So if we've got, let me get rid of this for a minute. If we've got x being 6 and you take 6 minus 1, that is 5. And is the absolute value of 5 equal to 5? Yeah. What if you say x is -4 minus 1, that's -5. Is the absolute value of -5 also 5? Yes, because remember, absolute value means how far away is it from 0. Okay, so on number 3, remember we said on the very first thing, if you go back to the beginning and you've got it on your notes up at the top, it says you have to get the absolute value equal to the number. So this part right here is the absolute value part. That +5 is a little bit of a problem. So we're going to move it. And we move it just the same old way we've been moving things all along. So I'm going to do the right-hand side first. 32 minus 8 is 24. The reason I want to do that first is because this is where everybody makes the mistake. People just write 5x minus 6. Thanks for playing, but you're wrong. You have to keep the absolute value signs. It's really important, and we're going to find out why in the next slide, okay? Now, you have absolute value equals a number, so you can take those two bars. You can take 5x minus 6, take it out the door to the right. It could land at 24. You could take 5x minus 6, take it out to the door to the left. It could land at -24, because remember, absolute value is how many steps did it take away from 0. Then we just solve the regular old way, and I'm just going to kind of zip through this because we have been solving equations forever. So we know how to solve these. You don't really need me to talk you through it because my nasally voice drills on and on and on. On this one, however, remember, we're going to leave it as -18/5. If that bothers you, you can make it into -3 3/5, but We don't ever use mixed numbers in arithmetic, so we're going to leave it as an improper fraction. Okay? On number 4, here is the absolute value sign. Now, this is really, really important. Write this down. You cannot, capital letters, I'm screaming at you, you cannot distribute into absolute value signs, okay? You cannot distribute that 4 into the absolute value signs. Absolutely not. Absolute value is absolute. It has to stay alone. So when I go back to this problem, I have a multiplication problem over here. 4 times this absolute value. I got to get rid of it. Opposite of multiplication is division. So I'm going to divide both sides by 4. What do I have left? The absolute value of x plus 5 equals, and 20 divided by 4 is 5. And now it's time to take it to the left and to the right. So x plus 5 walking to the right ends up at 5. X plus 5 walking to the left ends up at -5. Solve the equation. X would equal 0. Solve the equation. X would equal -10. So we have 2 answers for every problem. Oh, 2 sticks, 2 equations, 2 answers. Oh my, so exciting. Okay, so here's the one I wanted to tell you about. Absolute value equals -12. So here you are on your little number line. You have to go 12 backwards. Nope, that's not what -12 means. The absolute value means you are 12 negative steps away. Nope, you can't be 12 negative steps because you can't take a negative step. If you take a step backwards, you're still taking a step. If you take a step forwards, you're taking a step. Left, right, whatever. You can't take a step that's negative. So here's the deal. An absolute value cannot, again, I'm yelling at you, cannot equal a negative number. And I use the hashtag there. That's actually a number sign, okay? Now, you've got 2 criteria here, though. First of all, number 1, before you make this decision, if the absolute value, look how lazy I am. I'm just going to write abs val, is isolated. Okay, so you cannot make this decision until the absolute value is alone. Like I can't make that decision. Look at number 6. I can't decide right now because this side's negative. I can't decide that that has no solution because it's not alone. So the absolute value must be alone. And what's the other thing that it has to be? If the absolute value, once it's alone, equals a negative number, then there is no solution. Okay, again, the reason for that is it's not saying you went -12 steps. It says you went 12 negative steps, and you can't do that. So once it is isolated, this is huge, guys, has to be isolated, and it equals a negative number, then there is no solution. So this answer is no solution. So on number 6, remember I said we can't make that decision. A lot of people go, oh, -10, no solution. Don't do that. First of all, though, you got to look at this left-hand side and say it's a hot mess. So what do you have to do first? You always move, just like in regular solving, you move the minus or the plus first, okay? So I'm going to add 4. Why do I not take care of this -3 first? Because it comes first, because it's multiplication. So just like if I had -3x minus 4 equals -10, I would take care of the addition first, okay? So that's what I'm going to do. Move the plus or minus first. Don't forget, when you tell me what's left, to include those absolute value signs. After you move the plus or minus, then second you do the division, okay? So now I'm going to divide both sides by -3. Make sure you take the sign. That's huge. What do I have left? Don't lose the absolute value. 2x plus 1, the absolute value of 2x plus 1 equals 2. Look at that. Now it is no longer equal to a negative number. So now that tells me I can do the problem. So I'm going to set up my right and left. 2x plus 1 could go 2 steps to the right. 2x plus 1 could go 2 steps to the left. Solve it the regular old way. 2x equals 1. Divide by 2. X is equal to 1/2. Bada bing, bada boom. Solve it the regular old way. 2x equals -3. X is equal to -3/2. Now here's the problem, guys. If you don't recognize this situation over here, you will get 2 answers because you will be able to solve the equations once you drop the absolute value sign. So you got to be really careful to look for that. All right. Now you think we're on the downside here, but this is the part that gets everybody. This is the part where when we have time for our quiz or test, this is where people are going to get it wrong. Excuse me. And if you notice, it's really little and there's only one problem because we got a lot of work to do. So first of all, this is the big thing here. This is the change. There is a variable outside the absolute value sign. Got a variable inside, got a variable outside. That's the difference. We haven't had a variable outside. So to do this, first of all, don't forget the absolute value must be isolated. That can be the only thing on its side of the equal sign. We've got that. So we're ready to take our 2 steps. Well, here's the first thing. If x plus 1 goes to the right, it could land at 2x plus 4. We don't know what that is, but that's where it would land. What if it goes to the left? Well, remember, if we had the absolute value of x plus 1 equals 2, we would have taken it and had it equal 2, and we would have had it equal -2 because that's the opposite of that, right? It goes in the opposite direction. So what I have to do is I have to take the opposite of the entire 2x plus 4. Opposite in math is a negative. So what I'm going to do is change 2x to negative and 4 to negative. You have to take the opposite of each term. That's what that step says. Okay? Now I'm going to solve them. I'm going to subtract 2x. I get -1x plus 1 equals 4. I'm going to subtract 1. -1x equals 3. And divide by -1. And I get x equals -3. I'm going to do this one same way. Okay, blah, blah, da, 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 da. We're just going along solving equations. And we know how to do this. So here we go. Enjoy the show. At this point, do not move on. Here's the important thing right here. Let me get a new color. I want a new color here. This, huge. That's the wrong kind of star, people. This is, let me introduce you to my dear friend, Mr. Biggie Wow Wow. This is the Biggie Wow Wow. This is the part that everybody messes up on. If you have an X outside, you have to check your solution to see if they work. Okay, you could get what is called an extraneous solution. What that means is this -3 works for this solution, this -5/3 for that equation, that works for that equation, but does it work when the absolute values are in there? Because remember, if I get the absolute value equal to a negative number, it doesn't work. So over here, I'm going to put my check. These get a little messy, guys. So I'm going to take the original problem, absolute value of x plus 1 equals 2x plus 4, and I'm going to use x equals -3, okay? So I have the absolute value. Plug in that -3 for your x plus 1. I want to see if that equals 2. Plug in that -3 for your x plus 4. So this is the absolute value of -2. For the sake of space, I'm going to say this is -6. -6 plus 4 is -2. Can the absolute value equal a negative number? No. What that tells us is x cannot equal -3. That is what we called an extraneous solution. Okay, now we got to try. We got to try going back to x plus 1. This one's a little more work. Equals 2x plus 4. And we're going to let x equal -5/3 to see if it works. So the absolute value of -5/3 plus 1, we're going to see if that equals 2 times -5/3 plus 4. So you can go to your calculator or you can actually use math. -5/3 plus 3/3, that's the absolute value of -2/3. Okay? Then we've got 2 times -5/3, that's -10/3. Watch what I'm going to do. I'm going to change 4 to 12/3. Tricky, tricky. That equals 2/3. So my question is, are they equal? The answer is yes. Therefore, x equals -5/3 is our solution. The reason they're equal is the absolute value of -2/3 is +2/3. Oh my gosh, mind blown. You might have to watch this slide again. All right, so let's do another one. First question, is it isolated? Yes. So we are going to go to 4 minus 5x equals 3x plus 2. The other equation is going to be 4 minus 5x. Absolutely do not ever change the stuff inside the absolute values. And then opposite of 3x, opposite of 2. Okay? We're going to go ahead and solve these just the regular old way. I'm just going to walk through it here. You know how to solve equations. You're smart little cookies. Okay, this is where people mess up though. -2 over -8. First of all, the negative over negative cancels into positive, and 2 over 8 simplifies to 1/4. All right, if you don't know how to simplify and you need some help, ask your teacher. She can reteach you simplifying fractions, or she can show you how to use the ABC key on your calculator. Great device. All right, plus 3x. The ABC key is a great device. It will simplify it for you. However, you cannot use it on all standardized tests, so that's why you should honestly know how to do it without the calculator. All right, negative over negative becomes positive. 6 divided by 2 is 3. So over here, I'm going to start up a little higher. I'm going to do my check. So the first thing I'm going to do is absolute value of 4 minus 5x equal to 3x plus 2. And I'm going to see if x equals 1/4 works. So I have the absolute value of 4 minus 5 times 1/4. Does that equal 3 times 1/4 plus 2? So over here, I have 4 minus 5/4. I'm just going to keep working down the left-hand side. That's 16/4 minus 5/4. I got to write smaller, people. I'm going to run out of room. That is the absolute value of 11/4. So what I'm trying to see is, does the other side equal 11/4? So this is 3/4 plus 2. That's 3/4 plus 8/4. That is the world's worst 11/4. It checks. Happy, happy. Put a box around it. We found an answer, but we're not done. Now we have to go back up to the original, but this time we're going to let x equal 3. So it's the absolute value of 4 minus 5 times 3. And we want to see, does that equal 3 times 3 plus 2? So I'm going to do the left-hand side. This is 4 minus 15, still in absolute value bars. That is the absolute value of -11. So what am I looking for on the right-hand side? Does it equal positive 11? 9 plus 2 is 11. Does it equal? Whoop, whoop. Happy check. You got it. Put a box. We got 2 answers, 2 solutions. They both checked. Life is good. All right, last example. First of all, is it isolated? Yes, it is. Now, this one's a little tougher. So you know what I'm going to do? I'm going to cheat. I'm going to rewrite it, because I don't really like the absolute value on the right. So I'm just going to write the absolute value of 2x plus 10 equals 7x minus 5. All I'm doing is moving the two sides. It's called the symmetric property. You'll learn all about it in geometry. So first of all, 2x plus 10 could equal 7x minus 5. Scenario number 2, 2x plus 10 could equal opposite, opposite. Remember, on this side, it's opposite, opposite. Okay? So we've got, oops, what am I doing writing in red? Goober, goober, McGoober sign. So we've got minus 7x minus 7x. So we have negative 5x plus 10 equals negative 5, negative 10, negative 10. Negative 5x equals negative 15. We are suggesting taking up for consideration the actual value of x being 3. We're also over here, what are we going to suggest on this one? See, right now these are just suggestions because we haven't done our check, so we can't put them in boxes yet, guys. Divided by 9, divided by 9. The possible solution here is negative 5/9. All right, I'm going to check the red one first, and I'm just going to plug it in because you guys have this now. Remember, I'm going from here, from the absolute value. Absolute value of 2 times 3 plus 10. Our question is, does that equal 7 times 3 minus 5? That's a question mark, guys. That's a horrible question mark. Left side, 6 plus 10 in the absolute value sign, absolute value of 16. So what am I looking for on the right? 16. So over here, I've got 21 minus 5, 16. Is it equal? Yep. Whoop, whoop. Happy check. Box. All right, let's do the second one again. I'm going from here, but I'm letting x be negative 5/9. 2 times negative 5/9 plus 10, all in the absolute value sign. Does that equal 7 times negative 5/9 minus 5? That's our question. Question mark. So over here, I have the absolute value of negative 10/9 plus 10. That's the absolute value of negative 10/9 plus 90/9. That is the absolute value of 80/9. So over on the right-hand side, I'm going to have to write little. I have negative 35/9 minus 5. 5 would be negative 45/9, and that comes out to negative 80/9. Can the absolute value be a negative number? No. So this is not a solution. Remember, the big word is, it is an extraneous solution. Notice how lazy I am for extraneous. This is a really long video. I really am sorry. It's almost 25 minutes. Well, it's actually 23. But there you go. These are absolutely not that hard as long as you remember to rewrite it as 2 equations once you've isolated the absolute value. Have an absolutely good time.